Okay. See, we got this, we do have this little lip right here. You can move that bottom Z down a little bit. We'll just leave it like that for now though. Okay, so let's go ahead and simulate the chamfer. Okay, so now what we're going to do is we're going to do a 4-axis facing operation. And what we're going to do here is, if you look, let's take a look at a multi-viewport layout. If you look at this, and let's go ahead and set. Okay. In 4-axis, if you think of, you're familiar with 2-axis. In facing, obviously, you're just doing a linear plane. So in 4-axis, if you look at it from the front view or directly on, you can consider the face being a location on this surface. So it's going to face at that level, at that radius, and it's going to face all the way around, versus like on a 2-axis, you're just doing it in a rectangular area or a predefined area. So in pocketing, you can consider that the same way. In 2-axis, you're defining your boundaries like a rectangle or whatever that you're going to pocket, and it's going to go down to a certain depth. You can consider pocketing in 4-axis to be similar to that, where you have an upper level and a lower level that you're going to pocket down to. We're going to go ahead. Go ahead.
Hey, Don, one of the things I want to explain about our 4-axis, some of our customers might have heard the word wrap machining. So in reality, what Don is describing here with the facing is really what we are doing internally is wrap machining. We're taking a linear toolpath, which is basically facing would be a flat toolpath, and taking one of the coordinates, in this case, the y-axis, or I think the axis is about the y-axis, so we would take the x-axis and wrap it, basically convert that to a rotation. So basically, we're taking out all the x. I'm sorry, we're taking out all the y, and then converting that to a rotary axis. So that in turn, what happens is it takes a flat toolpath in 3-axis or 3D space and converts that into a cylindrical space, if you will. So it's on the top of the cylinder. I hope that makes sense.
Mm-hmm. If you guys got any questions, just type it in there and we'll get to it. Okay, so we're going to do a 4-axis facing to face off this upper diameter here. So let's go ahead and go into 4-axis. We're going to pick facing. And in the picture right here in the dialog gives you a really good idea how this works. We're not going to be going along the axis. We're going to be going around to get a better surface finish. But we're going to pick 2 areas to face. Now, the boundaries if you think in 2-axis, you got a boundary all the way around that you're probably going to pick, or if it's an open face, maybe three edges. In 4-axis, you're picking 2 cylindrical areas on the right and the left. So let's go ahead and we'll pick our curves. We got 1 cylinder here, and we got another on the end right here. So we're going to be facing between these 2 curves. So we'll right click. With the tool, we're going to go ahead and use the 3/8. And actually, let's see what. Okay, so we're using an extra 1/4 inch. I have the finished drawing over here on another screen I'm looking at here. So let's go ahead and do the 3/8, or close to not 3/8, 1/4 inch. Okay, looks like I don't have a 1/4 inch. We'll use the 3/16 would be fine. And let's go to roughing, and we're going to go ahead and set the tolerance to 1000, the stock to 0. We're going to be doing linear cuts or around it, excuse me, and we're going to do a mixed cut direction. And for angle of cut, 0 means it's going along the y-axis back and forth. So we're going to set this to 90 degrees to go around it. And for the start point, we'll leave that there. The step over, that's fine. Cut levels. Where's our geometry? It's at the bottom of the cut. We're going to pick at bottom. And If you had some extra material, you want to come down, you know, in multiple levels, you can use this, but we're just going to set it to at bottom 0, so the cutter is going to cut right on this top cylinder here. So facing entry and exit, that should be fine. Let's go ahead and generate that. So you see what it did. It went around the axis with our offset, and it worked its way from one cylinder to the other. So let's go ahead and simulate that. We'll turn the toolpath off. Let's go ahead and play that. And the reason we're going around it axially is to get a better surface finish. The flat mill will be a perfect surface finish on the cylindrical part. If you did it long ways, you would see some cusping of the tool as the part stock rotates around. So we're going to do it around the axis to get the best surface finish.
So Don, there was another good question about the curves that you selected. If you can go back to that program tab, I want to see. Yeah, Don selected the curve that was not right on that rectangular block, but it was actually offset by tool radius. And the reason he had to do that is to make sure that the tool does not, gouge into or hit the rectangular block. So if he had selected the intersection of the cylinder with the rectangular block, that would have actually cut into that rectangular block. So that's why he had to offset it by tool radius.
So if you're familiar with some of the other webinars where we talk about contact points for what tool types, in facing, the axis of the tool or the tip of the tool will be on the geometry, on the boundary that you select. So the actual tool center is going to be on this curve, as Joe mentioned. That's why we offsetted it. Okay, so next we got a facing done.